Welcome to IDA's video channel. In this video, I'll show you how to run a system curve analysis. In this video, I already assume that you watched the other previous videos where I cover how to analyze bulk water pipeline that is connected to the existing supply node. And also, I assume that you watched a video about the settings for the analysis. So I'm not going to go to too much details. I will take you through the entire workflow. At the beginning, I have a reservoir which serves as an infinite source of water, and on the other hand, I have a tank because I want to pump the water into the tank. But to find a suitable pump, I need to run a system curve analysis to find out what are the losses in a system. Let me zoom in this location because I want to insert pump somewhere here. But because I want to run a system curve analysis, I'm not going to use pump. I will use a normal junction, and only when I run the analysis with a pump, I will swap it to pump. So I'm going to insert structure. If you use a compact ribbon, you can go to IDA's insert structure. If you use extended ribbon, you can go to IDA's network edit, and then you can go to insert. Specify the network, specify the surface name. As a node, type J for junction and select junction, and interpolate structure depth from current pipe slope, or you can specify the cover, it's up to you. Click OK and specify the location. Select the node and go to node properties. In the node properties, I will change the name to pump. So this is a node, normal junction, but the name is pump. So it is easy for me to identify this junction in the pipe manager. Then I click OK. Then I select the very first pipe because I want to go to its properties. This pipe name is P1. I can keep it P1, or if I want to, I can call it P1 in. This is an incoming pipe into pump. And for the following pipe, I will do the same. I go to pipe properties, but as a pipe name, I will use P1 out. So this is a pipe outgoing from the pump or future pump. Currently, this is just a node. And I'm ready to go to pipe manager or manage and analyze. If I use an extended ribbon, I go to manage and analyze. If I go to compact ribbon, I go to pipe manager. Then you're already familiar a bit with this interface, so I'm going straight to structures. And then under the reservoir, I need to specify the properties. I have a reservoir name. The connected pipes are open, there's an invert elevation, depth below surface, and the water depth, which is actually the pressure. And I want to use 2 meters. It gives me the total head. There's also an option to specify the head pattern if you need to. Then let's go to tank. We have a tank at the end of the network here, and the tank has a specific size, so I need to specify its properties. First of all, I need to specify the shape. There are 3 options: cylindrical, box, or other. I will keep it simple. I will use a cylindrical. If you use box, then you must specify the tank area. There's also an option to specify the volume curve. Then there is an invert elevation, the height above surface. If it is negative, it is below ground. Inlet position. There is an option that you can simulate the atmospheric inflow. If you use NA, not applicable, it means that a pipe is connected at the bottom of the tank. And if you specify one of those, then you must specify the inlet elevation of that connected pipe. Then there is an initial water depth. We need to specify what's the water depth in a tank at the beginning of the analysis. I will use 1 meter. It shows the exclamation mark because it's above the maximum level, so it shows you that there is something wrong. Minimum water level, I don't want to go below 0.1, and the maximum, let's say 4 meters. And as soon as I do that, the other exclamation marks disappear because now the software is happy with the settings. Then under the tank diameter, I need to specify that. And if I use a real size, what might happen that during the analysis, the tank might get full because I don't have any draw from the tank, which means the tank gets full and the analysis will be halted. And I don't want that for now. I will be doing that when I do the tank sizing. I will be interested in the tank size. But in this case, I just want to flow through the system and I don't want the tank to have any impact on that. So I will use a very big diameter, let's say 1000 meters. So it means the tank will never get full during my analysis. If I run the analysis, let's say for 24 hours. Then I go to pumps. I don't have any pumps, no valves, junctions, bands. And here I have a band which is called pump. But before I do anything else, there is an exclamation mark. And if there's an exclamation mark, you should probably fix that first. I did it for a purpose, because it often happens that the users have quite a few errors in their network. And then they send us drawing for a support. So we explain them that they must fix those problems first. So it says the name limited to 15 characters. And this name is longer. So it's HB1, ABCD, whatever. So let me fix this problem first. I go to update because I want to save any changes I did already in this dialog. And then I search for the network. I go to find part in a compacted ribbon. Or if I want to use extended ribbon, I go to network edit, find part. Then I specify the name HB1. And I can either go to plan or to profile. Doesn't really matter. Okay. I can select it. I go to structure properties and I will adjust the name HB1. OK. And I'm ready to open pipe manager or manage and analyze. I go to structures, junctions, bands, and there is no error. I go to pump. So this is my future pump and I want to find out what are the losses in the system if I have a pump at this node. Let me zoom in plan. So this is that specific node. What I can do, I can let the water to get into the system and flow through the system, and I can calculate the losses through the system. And for that, I can use a demand, but if I use a negative demand, that's actually the inflow. So I will do that, minus 22 liters. I would like to achieve something close to 22 liters per second. So that's why I'm using this value. But I want to find out what are the losses if the flow is lower or bigger, because I need to get a system curve. For that, I will use a pattern, but pattern must be created under library. So I go to library, patterns, and I create new pattern. As a name, I will use a pump, and number of periods, I will use 5. And then for each period, I will define the multiplier. I will use a 0.5, 0.75, 1, 1.25, 1.5. So these are the multipliers that will be used to multiply the inflow into the system. So I go back to structures, pump, and I can specify the pattern, pump. But if the water flows into this node, it will flow both directions, and I don't want that. I don't want any water to flow back to reservoir. So I need to close P1 in. I go to conduits, pipes, then I find out P1 in, and I will change the initial status to closed, which means it will not flow backwards through this pipe. You can see some exclamation marks here. The roughness coefficient is too small. If I go to hydraulic parameters, I can check the head loss formula, as I've shown you in other videos. And I'm using Darcy-Weisbach, so in a help file, in IDOS help file, you can find out the suitable values. In this case, I have a HDPE pipe. The suitable value might be 0.0015, so I select all the pipes. Then I right-click anywhere, and I go to roughness coefficient, and I go to 0.0015 as a roughness coefficient. There are some exclamation marks. For example, the maximum distance between the structures is more than 80 meters. And the velocity is smaller than specified value. This value comes from analysis. Here I specify the minimum velocity. And this value comes from profile view, where I can specify maximum structure spacing. But I can ignore it for now because this won't have any negative impact on my analysis. You can also see that some pipes are actually different. And you will see it in the results that they will be different. If I want to, I can swap them now to different type as well, or to match the other type, but I will leave it for now as it is. I can also specify the duration under the time and energy. The default analysis duration is 24 hours, but since my pattern has only 5 items and the first time period runs at time 0, I can run it only for 4 hours. So let me change it so that the end date will be the same as the start date and the end time will be 4. But if you don't change it, nothing happens. Your graph will just repeat again. And I'm ready to run the analysis. I can go to ribbon analysis and analyze, or I can go to plan, I can right click and go analyze. Again, the difference between analyze and peak flow is used for the water reticulation networks where we have a house connections and fire hydrants, and we need to combine various house connections with the fire hydrants to find the peak flow. While for this type of analysis, we use a standard analysis. So let me analyze. Okay, and let's go to report, analysis report. Here is the report for 4 hours, and we can see the results. For example, here the inflow is -11, which is half of the 22 liters per second because the pattern multiplier is 0.5 and so on. As you can see, multiplied by 0.75, multiplied by 1. If you want, you can go to graph and you can display results in a graph. You can sort by name, for example, and for the pump, you want to display the pressure. And here you can see how much pressure for each time you need, but you don't know what's the flow unless you remember it. So you can also display demand. That's that negative demand is inflow. If you want to adjust this graph, if you move the slider, it will refresh the view. And here you can see we have an inflow of 11, inflow of 16.5, 22, and so on. So you can at least match it. And if you still don't like this graph and you would like to have on a horizontal axis, you want to see the flow and the pressure head on the vertical axis, you can still do that. Let me show you how. If you go to report, analysis report, you can select everything, select all, and then you can right click and copy to clipboard. Then you can open Notepad. Okay, that's fine. Then paste it in and delete the stuff at the top from the first node results. So like that, we don't want it. And then you can save it. I will save it as, and I will save it on a desktop. I will call it report. Then I close it. Then I open Excel or any other tabular editor, but I'm using Excel because most people are using Excel. And then I go to File, Open, Control O, and I go to Desktop. I change the file of type to text file, and I will select Report. I want to delimit it by fixed width, then I go to Next. Unfortunately, this view is very limited. I feel like 20 years ago in a software, but unfortunately that's what it is. Maybe this one should be moved a bit, but otherwise it looks okay. Then next, that's fine, finish. And now I can select all the columns and I can go to filter, filter, and I want to select all the nodes that do have a name pump. Okay. Then I can copy these values, Control C. I will paste them as the values. Okay. I need to delete this middle column, delete because I want a flow and pressure head. If I want to, I can multiply these values, multiply by -1 equals this value multiplied by -1. I can use it for all of them. Then I copy this value, I paste it as a value. Okay, and I can delete those two columns. Delete, and I can select those two, insert, and I want to insert chart, maybe this chart. And if I want to, I can add an axis title, and this is a flow, and this is a pressure head or head, depending how you want to call it, pressure head. And this is a system curve. You can use a system curve or the values to find out suitable pump. You can use some online software, or you can contact the manufacturer, or you can use some graphs from the pump manufacturer. Once you finish with a system curve, you should always go back to Civil 3D and you should change the settings back. So go to Structure, Junctions, Bend, and then for the pump, remove the demand and change it to 0. Because in the next exercise, we will swap this junction to pump and we don't want any surprises. And then the pattern, change it to none, and then go to conduits and make sure that the conduit P1 in is open. And now we are ready to run an analysis with the pump once we find a suitable pump. I will also close this window, so I go to update because I want to update everything I did so far. But I don't need to update the results. I'm only interested into geometry.